Good morning, my YouTube channels. Today I want to show how to extract NASA Earth Exchange Global Daily Downscale Lit Climate Projection by Python or Anaconda programming language. So first of all, you must be download Python again Anaconda and install in your computer. Then after you install it, you want to open Anaconda. Here is the Anaconda prompt. I'm already installed Python. Look, here is a Python. Yeah, here is a Python version 3.13, and I'm also installed a Anaconda. So here is the Anaconda. Here is the Anaconda. So here is the method to analysis of extracting future climate scenarios by the latest SSP shared socio-economic 4.5 and 8.5. So later we can open D, or D means volume. Okay, then cd GIS Python. Here is my programming, my folders, programming, then enter, then Jupyter, open Jupyter notebook, Jupyter notebook. So wait until to open Jupyter notebook in the browser. Yeah, good. So here, so I'm creating your folder. You see here is my folders. Look, I wanted to show. Here is D. If you see, here is GIS Python programming, and I'm creating subfolders CMIP6, SSP4.5 and 8.5. Here is the satellite data which I download from the website. So I wanted to open here. You see here, and here is the latest scenarios. The latest scenarios you see here is first you can install these parameters, these important parameters, then run. Here is a run. Again, here is the file. You can define the file rd GIS Python programming. Here is the subfolders. Here is the downscaling satellite data. Look here. You see, copy. Look here. You see, here is copy. It is the same again. Below also the same. So you can define this file. For example, I want to extract. Let the output is Girma YouTube extracted precipitation. So again define this. Here is define. Again go to this data. So you XR, here is the XR is about the import file to open the dataset, then run. Good. If you run, go down, you can define the location, write the defined location. ID number is 1, 2, up to 8. The name is Babli, Haromaya Dradawa, Metho Adama Degam, Kuyu and Aboti. There are on latitude and longitude. So you can define here again. Define it or run it well. The second step is you can define DS or dataset. What about the dataset coordinate, latitude and longitude? Again, the precipitation. You know, it is the precipitation. So first you can define here dataset. again, after you can define the data set, you can define again also precipitation parameters. Good. Again, define the output data. So it is good again. So the next is define was the extract of data for the each location. You see it is the latitude is the IDX, longitude. Again also this is by the latitude is the capital letter, longitude is again is the abbreviation. So create the data frame, date, precipitation, ID, name, latitude, longitude, and output by the append objects, then select and run it. Good. The second is to combine all data and to save to CSV files. So select it, then run. The next is you know to calculate annual average of precipitation. Precipitation mean mean dimension and the time visualization plot of the figures. You know this is the figures of the height and the horizontal, about color, about X level, Y level, and the title is annual average of precipitation map or share socioeconomic 4.5 and 8.5. So you now select all, then run. So later we can wait until reveal it satellite image or map of the world. You see, good. Our procedure is correct. You see, here is the Babile, here is Haromaya, Dradawa, Mieso, Adama, Degam Kuyu, Abote station for 20, you see, for 2085, 85 future climate scenarios of precipitation. So I wanted to forward output. Let's select the final DVF. Here is the PD or concatenative output data, and save to the output CSV Girma. Let for example, here is the August. We are not in the August. We are September. September. Then run it. It is already saved. That we can see. Go to D or volume, go to programming, go to the CMIP6, then you see, look, here is the Girma YouTube extracted precipitation. Look, Girma, Girma YouTube extracted precipitation file. Let we can open it. It is really all the 7-8 station is present in here. Look here, if you see from 0101 2085, that is right precipitation. It is okay. You see here is precipitation, and here is the name Babele. What another? It is only Babele? No, here is Haromaya, here is Radua, Mieso, Adama, Degem, Kuyu. Look, that mean so we have 8 station or 8 study area. So we got such like a data and taken to the analysis to do the trend, to do the future impacts on a crop or cereal crop productions or on livestock, like a drought, like flooding. So it is very important. Again, also later we can change again. For example, if you wanted to extract 2050, for example, 2050, here is Here is the 2050, copy, copy 2050, for example, here is the 2050 again. Here is the 2050 again, Girma, for example, 2050, 2050 again also. So later we can again define. Look, it is clear. Okay, okay. Again, define. 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 Okay. Then define the data. Good. Good. Define the data. Define the location. Define the location. Again, define a data set. Data set. So define the data set. Define the precipitation. Here is the precipitation. Define the output. Run the output. Run the output and extract the data for each location. Okay. Again go down, combine all data and save to the CV. Look, okay, then show legend. Wait until visible map of the satellite image, or map of the world. Map of the world. Map of the world. Look. Map of the world. Wait. Yeah, excellent. Very good. So you see here is the annual average of precipitation. Annual average of precipitation for 8 location. So go to go to the forward to the output file to the concatenated. So run. Good. So later we can check again also. You see 2050, isn't it? Later we can open and later you can check. Yeah. So here is 2050 for all station, for 8 station. Look, from Haromaya, Adama, Dagam, Kuyu. Again, here is 2081. Look. Here is the 2080. Here is the 2050. 2050 for all station, for 8 station. So here is very important. You can take into daily, monthly, and seasonally. So interpret according to what you have the plan or your objective to analysis of the future climate projection. If you wanted to analysis the impact of climate change on cereal crops or on livestock, So here is very important, and you can practice it. You can practice and download Anaconda, again Python, and save it. Practice how to extract NASA Earth Exchange globally daily downscaling climate projection. So today my lesson topic is look like we will meet the next video by another research analysis. Thank you very much.